Gosh, I can't even hear it. All right, tell me when. I guess the class before, they must just ignore it or something. I don't know. Still there?
It's gone.
All right, outstanding. Started on that. So what we're doing tonight primarily is looking at polynomials, polynomial functions. Okay, we've already been looking at polynomial functions. So let me give you a couple of examples. A polynomial is when you have a sum and difference, whole number powers of x. Okay, so just let's write down a couple of examples. What you do to make a polynomial, just throw 2 or 3 x's there, put whole numbers on the exponents like that. You can put anything that you want to in front as long as it's a real number, and then you just separate things with plus and minus, okay? And that's what a polynomial function is. The key thing is you must always have whole number powers like that. Another example be something like this. You could have like x to the 7th, 2x to the 6th, minus 5, okay? You can have a constant term on there if you want to, and that constant term generally is represented by x to the 0 power. So that's what polynomials are. Okay, that's the easiest way to define those. So what we're going to go through real quick is we're just going to look, is this a polynomial? We're going to learn a couple of the basic things about this. So first of all, does number 1 look like a polynomial to you? It is, okay? So the terms are, this is what we call a binomial. It's because it's got 2 terms. So the 2 terms are 5x to the 6th and 4x to the 3rd, like that, okay? The degree, do you guys from your background know what a degree of a polynomial is? It's the highest exponent that you find, so in this case that would be 6. How about leading coefficient? Do you know what that is? That's the number in front of the highest power, okay? So there's just kind of a lot of terminology on that, so your leading coefficient's going to be 5 like that, okay? All right, how about the next one? Is that a polynomial? Yeah, it doesn't matter if there's a square root there. Sometimes students think that that would cause a problem. The thing is, you've got whole number powers of x. This time it's 3 terms, so that's a trinomial. The terms are 3x squared, 5, and negative root 5 x to the 7th, like that. What's the degree? 7. What's the leading coefficient?
3.
No, the one that's in front of the highest power. Negative square root of 5, okay? Leading coefficient's defined always to be the coefficient of the highest exponent. Sometimes they're in a kind of reverse order. Okay, the next one, is that a polynomial? Yes, it is. Okay, here's why. Because that really is understood to have an x to the 0, and 0 is a whole number. So if you just have a constant, that is a polynomial. And since it only has 1 term, we call that a monomial. So we have like a monomial, a binomial, a trinomial. Beyond that, we really don't give them names anymore, but they're all polynomials. So the only term is there is negative 3. What do you think the degree is? 0. Good. Okay. And the leading coefficient is negative 3. Okay. Now, the x to the 0 is not there, and you want to recall that x to the 0 just is equal to 1, right? Anything is 0 is equal to 1. Okay. So that's the idea. Okay. Now, the next thing is, these are all examples of things that are not polynomials, okay? Let's look at why this is. The reason this is because this is, that what you're doing on this is not a polynomial. You're dividing 2 polynomials. So you can't divide. Actually, later in the semester, we'll work a little bit next week even on what we call rational functions. If you have 2 polynomials in a ratio, that's called a rational function. Okay, what's wrong with number 5? It's not a polynomial. It has that weird exponent, okay? You can't have no fraction exponents. You can have fractions as coefficients, but no fraction exponents, okay? And how about number 6? What causes the problem there? Negative 2, okay, right, okay? No negative exponents, okay? So you just got to have whole number exponents like that. So since we're studying polynomials, you want to be real clear on what they are, and then we'll kind of start learning what to do with these, okay? This one right here, let me explain this one. That looks like a polynomial because it's got whole number powers of x, but polynomials always have a domain. I want to say this, you can write it like this, must have a domain of all real numbers, okay? And so what I'm doing there, you can't have just like a piece of a polynomial. If I go from 0 to 6, that's only a piece of it. You want the domain to be all real numbers, okay? And then number 8, what's the problem with that? Probably. Yeah, absolute value, so you can't have that. Okay, so the purpose of that is just kind of to make sure that you know what polynomial functions look like, because we're going to do a lot of things with those. Okay, any questions so far? Okay, you want to know what the degree is, the leading coefficient. Those things are going to be important when we're running through these. Okay, now we're going to look at the graphs a little bit of polynomial functions. So first of all, this is the characteristics. You don't have any breaks. There's no sharp points like on an absolute value. And the domain's all real numbers. So what I'm doing is just giving some graphs, and we're going to look at whether they could be a graph of a polynomial or not. Okay, number 9, is that a polynomial? Could that be a polynomial? No, okay, because it has a sharp point. Okay, now this one right here, if you look at this, the domain's all real numbers, but you can't have a sharp point. Okay, that looks more like what an absolute value would look like. How about the next one?
Yes.
Yeah, there's no sharp point. It's going, domain's all real numbers. Okay, looks good. Okay, so that's a yes. How about number 11? Yeah, okay. Nice and smooth, no breaks, no sharp points. That's a yes. How about 12? Same thing. This is what polynomials are going to look like. How about 13? Nope, how come? It's got a break. You can't have any breaks, okay, like that. So they're nice and smooth. There's actually 4 ways polynomials will look. They'll look like this. They'll look like this, this, or this. There's 4. You want me to do that again? It almost looks like I'm doing a disco dance. Okay, you guys remember the movie Saturday Night Fever? Or are you way too young for that?
I'm probably the only one in the room who's seen that movie.
Oh, you saw that movie? Okay, I saw it back in about 1979 or whenever it came out, but that was John Travolta's pose. That was his pose. So would you like me to do it again?
Sure.
I'm kidding. Okay, let's move on to the next thing here. Now, I think didn't I give you a handout with these dancer figures on it? Yeah, so I need to load that up before I go through this. So this is called the leading coefficient test. And what it is this tells you how polynomials look. So what I'm going to have you do is just kind of write an example of each one. So if the highest power is odd and the leading coefficient's positive, then it does like that dancer does. I tried to find a dancer with each pose on clip art. So if you had something like this, just write down like an odd power. Let's do something like x to the third minus 1. That has an odd degree, and that leading coefficient is positive because that would be the number in front of x to the third. So what it would do is it would go like this. We call that the endpoint behavior, so it would kind of go like that. Okay? This thing right here is the y-intercept. So anytime you have that constant at the end, that's the y-intercept. So this graph would do something roughly kind of like that. Okay, that's the idea. So you want to know anytime it's an odd degree polynomial, leading coefficient's positive, that's what the graph roughly looks like. Now, if you had like a higher power, like a 9th power, 11th power, it may twist and turn and do stuff like that. But the idea is the endpoint behavior always stays the same. So what we say on this is going to negative infinity. And as we go that way, that goes to positive infinity like that. So that's the idea. That's dance move number 1. Okay? All right, dance move number 2. This is a cool disco man. So it goes like this. I'll give you an example. Say we have f of x equals negative 2 x to the third, and then something at the end, say like a plus 5. Okay? Now you can have all kinds of terms in the middle, but this one would go like this. Since it's an odd degree polynomial, that's a negative leading coefficient, then it just does the opposite of what the last problem did, because basically that's a reflection, okay? What's the y-intercept of my example? 5, good, okay? So that means you'd have a y-intercept like that, so the graph on that probably is going to do something like that, okay? So that's how you'll be able to tell roughly what these graphs look like, okay? Then we have even, and an example of this would be something like g of x equals, you already know parabolas, so let's just do something like x squared minus 5. Okay, that would be an even degree polynomial. The leading coefficient would be positive. So that one opens up. So like a parabola opening up. Okay, so you'd have kind of go like this, like that. You have a y-intercept of -5, so I'm just going to notate that as -5. So that's roughly what that graph would look like. Okay, as long as the highest power is even and the leading coefficient is positive, that's roughly what the graph will look like. You might encounter problems where it's a fourth power that might kind of look like that, but they still have the endpoint behavior. Does that make sense to everybody? Okay, that's what we're talking about, is what we call endpoint behavior. Okay, here's the last one I found. So this one, it would be an example like g of x. Say you've got -2x to the 6th -1 or something like that. Okay. Now what will happen on this one, since the leading coefficient's negative, it just reflects this upside down. It would go through that y-intercept of -1, but you don't really know what else it would do. I mean, it might twist and turn and stuff like that. So you don't really know exactly what would go on there unless you worked it out. So that's the idea, is you just want to know which of the 4 situations you have. Okay, everybody with me okay? All right. Okay, so let's kind of just do a sketch on each of these. Okay, so let's see. This one is number 1's odd. Leading coefficient's negative. So this one goes like this. And this is all you got to do. You just go like that and like that. And then you do have a y-intercept of -3, so I would like you to do that. Now, you don't have to fill those in. All I want is just, okay, that's the endpoint behavior, that's the y-intercept. What goes on between that could be anything, okay, doesn't matter, okay? All right, how's the next one go? It's an even power, leading coefficient positive. How does this go? Like that, very good. Okay, it's like a parabola opening upwards. So this one would kind of go like that, like that. You would have a y-intercept of -4, so you'd have something like that. Now, it may connect in lots of different ways, but that's the basic idea I want you to have down, okay? Next one is odd. Leading coefficient is positive. So if you have that, it'll go like this. As x goes to the right, y goes up. As x goes to the left, y goes down. Again, you'd have a y-intercept of -1. So that's roughly what I want you to do. Okay, I don't want the whole graph, I want the endpoints, okay? And then how does number 4 go? It's an even degree, so it's going to go down. It's going to kind of look like a U shape kind of going down. Leading coefficient's negative, even power, you're going to have a y-intercept of -1, and then just kind of going down like that. Okay, everybody okay with that? Okay, now that's something that you want to be sure to know, is the difference between those and what those rough graphs look like, okay? All right, let's see. Now let me go back to where I was a minute ago. And what we're going to do is we're going to look at just kind of some graphs, and we're going to see if we can figure out which ones these are, okay? So on number 14, tell me if that would be an odd degree or an even degree. Okay, that's good. Would it have a leading coefficient being positive or negative? Positive. Okay, that's what you got to know. What is the y-intercept on here? What does that look like? -5. Okay. So which one could possibly be an answer to this? There's only one. Yeah, that one's C. Okay. You got your y-intercept there. You got your odd highest power, and then that leading coefficient's positive. So that would be the one that it has to be. Okay. All right. Okay. 15. Tell me if it's even or odd. And I'm not talking about even odd function. Even degree, odd degree. What is it? Okay, it's even degree. Is the leading coefficient positive or negative? Positive. Okay, what's the y-intercept? 10. Okay. 10. Is it 10? Oh, I'm looking at the wrong thing. I'm looking at the wrong choices. Okay. So let's see. What does that look like that would be? Now, that looks like C. That would have the even degree, positive leading coefficient, y-intercept like that. Okay, so that's got to be that one, all right? Okay, next one, even degree, odd degree. Odd degree. Okay, leading coefficient, positive or negative? Negative, okay. Y-intercept, 0. Which is it? What do you think? A, yeah, good, that's A. It's got to be A. It's got the leading coefficient, odd, and there's a +0 there. Okay, like that. All right, everybody with me? Okay. Okay. So what we're trying to do right now before we start putting this all together is just kind of get to know what the functions look like. And that's a big purpose of pre-calculus, because when you go to calculus, you have to know functions real good. Okay, so we're just trying to get to know those. Okay, this one would be an even degree. Leading coefficient would be positive. Y-intercept looks like that is 6. So let's see, which one's that? Probably D. Yeah, it's got to be D. Now let me ask a question on this one. Let me ask you this. Why would it not be this? Let's see if we can understand this. Now a fourth power is always going to do that kind of thing right there. But what does that x plus 6 do to this thing? What kind of transformation is that? That's like left 6, isn't it? So there's nothing being moved to the left 6 on this or anything. And if you multiplied this out, you wouldn't have a y-intercept of 6. You would have a y-intercept of 6 to the fourth power, whatever that is. Okay, so that's the idea. Okay, now what we're going to get into next here is we're going to look at what we mean by a zero of a polynomial and what we call multiplicity and that kind of thing. Because what our goal is on this problem number 18 is to be able to construct a very accurate graph without even having to look at our calculator. So what we're going to do first of all on this is, and this part you can do in your head, this is already factored. Okay, so you can just write x plus 2 equals 0, x minus 1 equals 0. But again, you can do that in your head. Okay, we've already been doing that. So x equals negative 2 and x equals 1, those are what we call zeros of the polynomial, because if you plugged in negative 2, well, the whole thing would become 0. Negative 2 plus 2 is 0, the whole thing's 0. Same thing with 1, if you plug 1 in, the whole thing's 0. Everybody understand that? Okay. Now the multiplicity is the exponent on the factor. Okay, so that negative 2, that has a multiplicity of 2. Okay, and then this one, the x minus 1, that 0 of 1, has a multiplicity of 1. So it turns out what happens on this is if you have an even multiplicity, the graph will just touch the x-axis. Okay, it won't change directions or cross that. And if it's an odd multiplicity, it's going to cross. So what we're going to have on this one, since this is an even multiplicity, that means that's going to touch the x-axis. The other one has an odd multiplicity, so that means that's going to cross the x-axis. Okay? Now what our goal is to do with this is actually to sketch a very accurate graph of this without having to rely on the calculator. Okay, so let me show you how to do that. Just sketch yourself an xy axis, and then I'll show you how we do this. Okay, so we're going to try to piece this all together. All right, so what we'll do is we need to just go to where our zeros are. So we have a 0 at negative 2, put a dot there, and then you might put a T for touch. It's going to touch there. Then you have a multiplicity of 1. That's an odd multiplicity, so you're going to cross like that. Okay, now we have those 4 possibilities of how this goes, so the next thing we need to do is we need to figure out what the degree of the polynomial is, and we also got to figure out if the leading coefficient's positive or negative. If we can do those 2 things, we can put it all together. Well, really all you have to do, you don't have to multiply this out. If you multiplied all this out, like if you did x plus 2 squared, you would get an x squared, wouldn't you? And then if you took an x squared times an x, you would get x to the third. The degree really just comes from adding up those multiplicities. So you can write a note of that if you want to. That's the simplest way, is the degree is just going to be 2 plus 1, so that's going to be 3. So what that means is your graph is either going to do this, kind of like that, or it will do the opposite thing. Okay, that will depend on the leading coefficient. Okay, so when you look at the leading coefficient, this essentially is what you want to look at. You want to look at the x to the second and the x, like this. So you can do this in your head. What you're looking at is x to the second times x to the first. Okay, and if there was numbers in front of x, you would want to pay attention to those things. So what would you get? You would just get x to the third, which would have a positive leading coefficient, which would mean it's not that, it's this. Does that make sense? Okay, you don't have to multiply it out, you just got to look at those coefficients of x and see what happens if you multiply them out. So then this is what would happen. Since we know it's an odd degree and a leading coefficient positive, you're going to have endpoint behavior like that and like that. Okay? Now what you got to do is you just got to realize how this goes through. So what's going to happen, it's going to hit the 0. Since it touches, it's going to have to change directions. Then it's going to have to change directions again, and then this time it crosses through that and goes like that. Okay? You don't have to worry about what the y-intercept is on this problem. I'm interested in the rough idea. So that'll go to there, it'll touch, it'll change directions, go up like that. So I'm looking at the rough shape of this. I mean, you're never going to figure out exactly what the points are unless you did arithmetic and got your calculator out, but that's what I'm looking for. Does that make sense? Okay? So you can put together polynomials in a factored form by approaching it in this manner. Okay? All right, let's work with another one of these and kind of get the idea here. Okay, now on this problem, the first thing is, as a student that's already factored, you would want to tell me what the zeros are. There's 3 zeros. What are they? 0, 7, -1, right? Okay, you just look at those factors. You don't have to show any work on that. That right there is given 0, that's given 7, that's given -1. Okay, so we've got 0. Okay, what is the exponent around the thing that gave us 0? 2. Multiplicity is 2. It's even, therefore it touches. Okay. Then the 7, what's the multiplicity on the 7? That's understood to be a 1, right? That's a 1. That's an odd number, therefore it crosses. The multiplicity tells you where it crosses or touches. Okay. And then the -1, what's its multiplicity? 3. Okay. Odd tells you you cross. Okay, everybody got that? Okay. And the reason these things work this way, it's just the way the signs work out when you're kind of looking at how the signs work out, whether you have around odd or even exponents. Okay, now what we're going to do is we're going to try to sketch a graph. So let's go ahead and see if we can get this put together. Okay, so let's see. We're going to look at, you just need to really look at 1 and -1. And then we'll put dots on this. So it's when we have a 0 of 0, you're going to touch. At 1, you're going to cross. And at -1, you're also going to cross like that. Okay, that's the idea. Did I make a mistake somewhere? Oh, that one's a 7, right. Yeah. I don't know why I did that. Okay, so let's correct that. And then the 7 had a multiplicity of 1. Okay, so let me fix that real quick here. So I just need to take this out a little further. So I'll just go out and call that 7. And then that one will cross like that. Okay? Now, what we got to do is 2 things. You got to figure out what is the degree. What did I say is the easiest way to find the degree? Add the multiplicities, right? Okay? So really all you got to do is to find that degree is just do 2 + 1 + 3. So that's equal to 6. So how's the graph going to go? What are the 2 choices? Like that or like that? We got to figure out which. Okay, the leading coefficients, the next thing, this is the place where students have the most trouble is leading coefficient. What you're going to do is you're going to look at the -4x squared, just the x to the first, and the x to the third. You got to look at all those pieces of that problem. So you would have -4x to the second, multiplied by 1x to the first, multiplied by 1x to the third. What you're really doing is you're ignoring those numbers inside, like the 7 and 1, but you can't ignore the exponents because they make a difference in most cases. So now what you do is just figure out whether this is negative or positive. By looking, is that negative or positive? That's negative. It definitely is because you just have a -4, and then that would be x squared times x would be x to the third. That would be another x to the third, so it'd just be -4x to the sixth. So actually the leading coefficient, if you multiplied it out, would be that. So how does the graph go? If it's a 6th power and the negative leading coefficient, what's going to happen? It's going to go like this, right? Okay, so what you want to do when you start putting this together is you just kind of make an indicator to yourself that the endpoints are going to go like that. Okay, then you just kind of draw a really rough sketch. So this is going to go across the x-axis. It's going to have to change direction somewhere. We don't know where. It doesn't matter. It's got to touch. Now what does it have to do? It has to change directions because it can't go through. And then it's going to have to change directions like that. So that's what you would do. Okay? All right? good test question. It tests a lot of things, so you want to kind of be on top of what I'm doing here. This is kind of a basic thing that's already in factored form, and fill this out. That's a basic thing I want you to know how to do. Okay, any questions? Okay, and you can always check with your graphing calculator. Okay, the next thing I want to look at, this one's not in a factored form, but it is a polynomial. So what you have to do is you have to put it in a factored form. I like to start them by putting it in the factored form. So how do you factor number 20? You take an x squared out, good. So we need to go ahead and do that. So we'll have f of x equals x squared. Then we'll be left with, it looks like 5 minus x like that, okay? So we got it factored. That's all you got to do on that. So what are the zeros? There's only 2 of them. I don't know why I gave you 4 blanks. There's 2 zeros. What are they? Yeah, there's 0. See, that one's giving you a 0. Then that one's giving you a 5. Okay, so I don't know why I did that, but it doesn't make any difference. Okay, the multiplicity on 0 is what? 2. Right? Okay, does it touch or cross if the multiplicity is even? Touches. Okay, then the next one, 5, what's its multiplicity? 1. Odd, therefore it crosses. Okay, like that. Okay, so that's the idea. So what we do now is we try to put together a graph on this and just kind of see how it goes through these, goes through the points. So they're either already factored or you have to factor them. Okay, if they're not factorable, you have to use other methods. Okay, so what we'll have on this, we'll just go out to 5 and to 0. So let's see, we said 0 was touching, we said 5 was crossing. Okay, so now what we got to do is we got to find the degree. What's the degree? 3. Okay, add the multiplicities. 2 plus 1 is 3. Okay, leading coefficient. Really what you do on the leading coefficient is you look at this thing and you look at this thing and the exponent. That exponent's real important on that. So you would do x squared times negative 1x to the first power. Okay, don't ignore the exponents and don't ignore the number in front of the x's, but anything else you can ignore. Okay, now you can do it in your head. Is that positive or negative? That's negative, because see, that would really just end up giving you negative x to the third. So it's a leading coefficient that's negative. So this one would go like this. Okay, this would be the one, if it has a negative leading coefficient, you would be going like this, and then you'd be going like that on the odd power. Okay, all right. Now you just kind of make a sketch. So you'd touch, that would mean you'd have to change directions, and just kind of like that. Okay, again, students a lot of times ask, how do you know when to turn? I don't. I just know I got to turn somewhere. Okay, that doesn't matter. Okay, all right. There's more precise parts of that, like when you're in calculus, you can look at minimums and maximums and figure them out very precisely. Okay, and we've already done some of that with technology. Okay, any questions? You guys understand what I'm doing okay? Okay, there's not a lot to work out. It's just kind of knowing how the rules go and the multiplicities and the behavior depending on the degree. So it's a fairly simple thing to put together. Okay, so let's look at this. Now, we're going to talk about what a turning point is. And I'll explain why this is. You want to understand why this works. So a turning point just means it's going to change directions. We've already talked about function increases, function decreases. So when it changes from increasing to decreasing or reverse, then that's called a turning point. And what happens is we have this real simple rule. The maximum number of turning points is going to be 1 less than the degree of the polynomial. Okay? So let me explain why this is. Okay, let's take something like, and you can just watch this because I just want you to understand this so you can figure this out if you need to figure it out. Okay, let's just say we had x to the 6th. It would do this, right? Okay, it's an even degree polynomial, leading coefficient, it's going to do this. Okay, but want to show you what could happen. Okay, we're going to count the turning points. So what we could do on this is we could go kind of like this. That's 1 turning point, 2 turning points, 3, 4, 5, like that. Okay, now what will happen on that is that's the most it can possibly do because it's got to connect to that like that. And what you'll learn on this is a 6th degree polynomial has 6 zeros. So at the very most, it could cross the x-axis 6 times. It's possible to do that. So what will always happen on that is in order to connect from there to there, you got to have one less turning point than the degree. Okay, I'll do one other one. Here's like negative x to the 5th. Okay, that one would look like this. Your endpoint behavior would go like that. Okay, well, if I'm going to go from there to there, and you can't turn more than 5 times because you can't touch the x-axis more than 5 times. That's the key. You can only have a maximum of 5 zeros. So this would go like this. That's 1, 2, 3, 4. See? Okay, and if you did an axis on this, see, I've already touched the x-axis 4 times. Okay, and then I'd have to go down like that. That would be the maximum right there. Does that make any sense? Okay. That's the way that always works on polynomials, is you can tell what the maximum number of turning points is. You don't know how many it has until you do a lot of number crunching, okay? All right, this stuff we're going to do here is super easy. Tell me what the degree of 21 is. 2. What's the leading coefficient? -1. What's the maximum number of turning points? 1. And I hope that makes sense, because that's a parabola, isn't it? How many turning points does a parabola have? It has 1, right? There's only one place that it turns, because you're going to have a graph doing that kind of thing like that. Okay? How about the next one? What's the degree of this one? You have to think about 22 a little bit. 9. It's 9. Good. You don't multiply it out. There's no need to do that. It's just you have x to the 4th times x to the 4th times 2x. Okay? That's what matters in the problem. So those exponents add up to 9. So what's the maximum number of turning points? It's 8. Okay, we're not saying that it has 8 turning points. We're saying it could have 8 turning points. Okay, that's the idea. Okay, and this last one, what's its degree? 4. That one is 4, because you're really just doing the x's. That's all you care about, x times x times x times x. So it's going to have 3 turning points. So that's how that goes. Okay, so that's a kind of a brief introductory section. I'm going to close.